Alrighty, we should be ready to go again today. Alright, to get started. Day 3, got T-minus 1.5 minutes, so right on time. Got my mic set this time. I've got a couple more additions to make sure I don't have the instructions on full time again. Look at that. And I have a preview up so I can actually see what's going on. So I have no excuses this time for anything going wrong. But plenty of time to get things revved up. Oh, I should turn on my REPL. My REPL is not on yet. Go and REPL go. Not connected, not connected. There we go. And just to verify. Okay, we got input. So that's all set. That could have been a little bit of time lost later, but not too bad. Let's go for some nice water. Okay. All right, ready to rumble. 9, 8, 7, 6, 5, 4, 3, 2, 1. In we go. Okay. They're working on a piece of fabric and they need to know how to cut it. And each of them made a claim about which area of fabric would be ideal. The claims have an ID, a single rectangle with edges parallel to the edges of the fabric. So it's square sections of this big thing. Each claim's rectangle is defined by basically the left margin and the top margin, the width and the height. Okay, so that's a upper left coordinate basically, and a size. Oh boy, wow! So they have a very interesting format for these claims. Oh, this is gonna take a little bit of parsing. Fun, fun, fun. Okay, I'm gonna have to recall my regex parsing from last year, I think. Oh boy, okay. I might pull this up on the side. It's been way too long since I've actually had to touch this. Okay. The claims overlap. So we need to find out. Okay. Claims overlap with each other. And we need to find out what regions overlap. Like this area right here. This seems like you could... You know what? We'll brute force it for now. I think. We'll see how big the puzzle input ends up being. Oh, and I already broke my promise. I've been showing you Emacs the whole time. Okay, so we get a whole bunch of these claims. Claim 1 is that a rectangle starting at this corner and of this size should be suitable for the purposes intended. We get a whole bunch of those claims. ID, upper left, size. And we need to parse them out. So let's get this in our file. Okay. We're gonna have to parse it somehow. This is gonna be taking inputs, mapping it to our input. Okay. Pulling up all my stuff from last year because I want to see if there's anything we can reuse from all this. Well, okay, let's see. I might have to do this by hand because I need to figure out what the standard. Might not need that actually. There we go. So hash followed by numbers, flaw at, flaw. Okay, definitely did not like that. Is it applicable? Definitely doesn't like that. Okay, yeah, pattern's just a standard Java pattern then. Okay, I'm gonna have to look up some docs on this. So let's bring you along for the ride. Where was that? Not CLJ doc. I've got the wrong thing. Maybe. Let's see if they've got core in here. No, they don't. There we go. Okay, let's try RE matches then. I've just been using the wrong thing, basically, I think. Oh, hold on. That would explain it. And actually need to split it. Okay, there we go. I always get split wrong for some reason. There we go. Okay, that took way too long. Okay, so to parse the input of a line, we got our pattern here. We're going to want to let ID left top width height be the RE matches, regular expression matches of our line. There we go. And I'm going to make all these -s. Just make it clear that these are the string versions. Oh, you know what? And rest, let me see, not rest, groups, there we go. ID, left, top, width, height, be the So we're going to map all those to integer values, which thankfully we have, and toss them all using destructuring into individual items here. And now, lastly, we're going to go ahead and actually put this in a map that we can use. So ID, left, top, width, and height. Pow, just like that. We should have okay, just to vet that, let's go ahead and parse input, map with parse input. First, a parsed input is broken. Let's see, RE matches, oh, I need to actually give it my regular expression here, which is a line pattern. Okay, and that's giving me nil. Oh, I should actually rerun this. There we go. Right, okay, there we go. Nope, didn't like that either. There we go, okay. So let's just rerun that so you can see it. Let's check our first line here. One, 829, 837, 1122, that matches our first line up here. So we have our parsing thing working now. We've extracted the useful information. That took way too long. I'm gonna be so bad on this day. Okay. All that said, let's move on to the actual specification. So we need to find these overlapping areas. The quickest way I can think of to do this is literally to like create a vector of vectors and manually set each square in that region. Honestly, I can't think of a better way to do it. Mostly because you have to remove some things from play from other overlapping rectangles. So, okay, well we're gonna do this for now. How big is our rectangle? 1,000 inches. Well, at least 1,000 inches. Okay, got to be careful there. Okay, let's do this with, okay, I think we can actually do this in a very interesting way. Instead of keeping an entire map full of all possible things, since we don't know the size of our vector, why make that? We can instead do something where we go with each rectangle in turn, compare it with all rectangles with higher IDs in it, basically, or with lower IDs, whichever one. And each of them will generate a set of tiles that it overlaps with something else. And so we'll just keep aggregating to one big set, basically, of points that are used up or have been collided with. So all these X's we'll keep track of here in one giant set, and we'll just keep incrementing those as we compare with more and more rectangles. I'm sure there'll be inefficiencies with like continuing to compare a rectangle long after all of its squares have been used up, but for now this seems reasonable. I am sure that there's a much more efficient algorithm to do this though, and I'm gonna have to look that up later. So, brute force it is. Let's go. Okay. Whoops. Okay. This is going to be a deafen, not a death. I'm going to destructure a list of rectangles into a current rectangle and the rest of the rectangles in the list. And I'm going to say, oh, and we also need to take in a overlaps set. There we go. Okay. We should probably actually define, let's see. So how do we define what the overlapping squares are between rect A and rect B? This is a classic one, not too hard to figure out. That's going to be four. Let's see, X in So, the whole thing is that, what you're saying is that, well, let's see how to describe this. Basically, you have to say two of their corners are intersecting. What was the standard thing for this? It's been so long since I've had to calculate this thing. There's quick ways to tell if they don't intersect. If supporting functions, right of a rect is a so, for example, 3, 4, 5 by 4, 1, 2, 3, 4, 5, 6, 7, 8. It's the right-hand side, so the last thing that is inside the square, technically. Similarly, bottom of a rect will be let's be consistent here. This is going to be top of the rect. If you know what, just for consistency's sake, top of a rect is just the top. That way we're working with just raw functions instead of our direct keywords here. Okay, let's try that now. For size, if the left of rect A, I think that was the end of my music already, which tells me a lot about how quick I'm going. And I've been showing the browser again, haven't I? Alrighty, back to this. Okay. If my left side of the one rectangle is greater than the right side of the other rectangle. There's going to be a bunch of ore cases. So any of these basically disqualify the two rectangles from colliding in any capacity. Then we return an empty set. There are no items basically that could be colliding. Otherwise, let me think here. Or we can, I'm just overthinking this, and we can just brute force the entire collision by going through all the squares in one and seeing if it collides the others. Okay, well, let's try that. Brute force first. It can be elegant later. I think range is exclusive, though. Let me verify that. Exclusive, correct. Okay. This is going to be top to bottom. Let's see. And this is where I shouldn't have deleted all that earlier. Oh well. This is going to be an and. I think that's how 4 worked. Evaluate. It's either when or where. When. Let's be consistent. Convention. And build a set out of that. Parity exception. Right, I should actually build out something out of all this. Okay, so that should give us overlapping squares between two rectangles. Okay. So overlap each of those other rectangles with the current one. Then we're going to reduce using, I think it's set/intersect. No, not intersect. We want a union. Or actually, no, we can just into overlaps. Let me validate. I'm pretty sure that's the syntax. Into. I always go for the set operations instead of just using into. That's an intuition thing I need to correct. Yeah, that should be it. Into overlaps percent. Similarly, percent. Okay. Into overlaps. That actually reads really nicely. I actually really like that. Let's see if it works though, before I get too excited about it. Okay. Recur with other rects, and then we have the overlaps that get strapped into the path. Oh, that's beautiful. And then, so basically, we'll just rerun the function now with the remaining rectangles, and we'll compare them against each other. So this new rectangle at the front, the current one's already been taken care of. We'll just now check for overlaps of rectangles in each other, and okay, I think that's it. It doesn't like it. Where's my parentheses? Where's my bad parentheses? Oh, I set an extra one here at the end. Okay, let's overlap all parsed input with an empty set to start with. Boom. Is in rect, not happy. because I am wrapping parentheses around things that shouldn't need it. Oh no. Oh no, it's taken way too long. Oh no. What have I done? How big are some of these? Maybe I should have done that before I actually like ran this thing. They're all pretty big here. Like 20, 23, 24, 25, etc. Okay. So we're talking about sizes of around 400, 500 a piece, and we're intersecting them all. Oh no. Okay, I should have considered that. Let's not try and get it to render everything though. You might be able to shortcut it by having it just count them all. Let's put this down here. I'm going to use replace so that we don't lose the result here. Okay, this will take a bit again, but I think this will get us what we're looking for, even if it is slow. And I'm really gonna have to go back and take a second pass at this later. My REPL timed out. I killed my REPL. Okay, let's see how this thing is doing. I need to pop over, I think. Oh, that's not great. And I killed my music, I think. Oh no, it is! It's huge! I don't know if it's still running, the other one. Let's try this again. Oh, it didn't process. The other one was still processing, so that's what happened. So it was still running that whole time. It's gonna take another couple minutes to run. I really should catch this result. Oh boy. It's doing it again still. Okay, let's just try something here. Take 3 first input instead. Let's just see what happens when we run it against 3 of them. Why is it in replace mode? Okay. Well, this is odd. I think I really might have just killed my entire thing. Okay. Let's kill it. I'm gonna need to sysman on link here. Start a new REPL. I think this might be too big. I need to rethink this. Okay. Still 0. It's running 10 fine, it's just once you have to run thousands of them, it starts to slow down a good chunk. Okay, let's think about this here. Let's run some tests. Let's use actually one of the ones that they gave us in the problem statement. Left 1, top 3, width 4, height 4. Left 3, top 1, 4, height 4. Let's see what this gives us. We should be seeing an overlap of only 2 by 2 there. That should be 4, 4, 4, 5, 5, 4, 5, 5. So I'm seeing way bigger overlap than we should be seeing. I'm seeing a 3 by 3 overlap instead of a 2 by 2. So I have overblown right, okay, this is an issue with my coordinates here. A left is a left margin, not a left coordinate. So my left of 3, 1, 2, 3, 3, 4, 5, 6. So I should be using exclusive ranges here. So that's my problem, I think. One, 2, 3, 4, 5, 6. Still acting weirdly. Less than. There we go. Okay, that might be part of the cause of all that slowness. I don't know why the music pauses periodically on this machine. Now it's just gone. What gives, buckaroo? Firefox must be letting the tab go idle. Okay. Still gonna be 0. Let's take 100. Okay. I'm gonna take the chains off now. That's more promising, at least. I could probably do something where I like sort the rectangles so that I know which ones are going to be viable even. I could just jump out early, but one 104,126 is my answer. It's funny that I pasted it up there. Okay, well, that's part one. Ugh, okay. That took way too long, but at least not as long as I expected. So that's something. What's part two? Amidst the chaos, I noticed exactly one claim doesn't overlap by even a single square inch of fabric with any other claim. So I need to find one that overlaps with nothing else. And I can actually use the same code for that, I think. Okay, I'll delete this for now. I'll come back later and finish that up. So what we can do is we can say so if we got to this point, actually we could do a game of elimination with this, because as soon as two rectangles intersect, we can remove them for consideration entirely. Interesting. Okay, I'll just put this as rects for now. Let's make this rect set. Okay. So we'll assume we're receiving a set because that allows us to do a cursive stuff here in a bit. Let's just make it correct. Be the first item we can pull from the set. We don't care what. We just want a rectangle. Remainder. Okay, I need to check something here. Hold on. Okay, let's try. X and rest. One, two, three. And X and rest. Oops. He did not like that. Nth. Okay, so we can't just pull an item from a set like that. But maybe I can. Hold on. Let's just see. First. Okay, so you can do first. So I just can't do destructuring with it. So I can take the first out of the set. Remainder is... There's gotta be... Hold on. And I've done it again. Where's our set methods here? Oh wait, I'm using the wrong thing. Let's use the quick ref. Sets. Disjoint. There it is. So we'll remove that rectangle from the set entirely. Let's map our So we're gonna take each of those rectangles, get collisions of it. No, you know what? We can make this a lot simpler. We don't need to do any associations here. We're just going to filter down to all of the rectangles that actually did collide. Okay, those are all the rectangles that collided. AKA, they had some squares that were overlapping. If we get an empty set of collided rectangles, then the current rectangle clearly didn't collide with any of them. We know that's our guy. Otherwise, we'll recur with disjoint between the rect sets and conj collided correct. So we'll just take all the ones we know did collide and the current rectangle, just scoop them all together, get them out of the set, and we'll continue with the next ones. So this will make sure we have a rolling kind of removal of disqualified rectangles, I think. Fingers crossed. Non-overlapping with our parsed input as a set. Fingers crossed. I'm really hoping this set and map and everything play well, because I'm never quite sure how set behaves in enumerable or sequence-like scenarios. Still taking a while, which makes me a little worried here. Yeah, I killed it again, I think. Or it's just taking its sweet time. It's acting like it's writing something, but it's not, which is worrying to me, to say the least. It keeps saying the buffer's been modified. Okay, I might have to do the same thing again where I kill that REPL. Not a good choice, huh? Okay. Do another assessment on link. Let's give it a second to actually load up that REPL. Should get a state on it. There we are. Okay, I should be able to run the buffer. That's all our definitions up. And now I should probably just be patient. Replace that section. Okay, it's processing now. Even with the removals, it's taken a while, which makes me concerned that I have something seriously wrong in how this is implemented. Let me check how disjoint works, actually. DISJ, it probably does not take a vector of things to be disjoint from. That would explain it. I'm actually probably running into an infinite loop here. Yeah, that'll do it. Okay, that's what I'm doing. I'm actually killing my REPL with an infinite loop. Okay. Where was I? I just bounced all over the place here. Okay. I think it'll have unlink already. Okay. But now I know what to do. So my problem here is that what I'm doing is I'm literally saying remove the set of all things as its own element from the list. But that's like saying remove the set itself from the set. It doesn't make sense. You have to remove the individual elements from the set. So if I have a set of... It's like I'm trying to say, hey, remove from this set of 1, 2, and 3 the array or the vector 2, 3. And that doesn't make any sense. I would have to have an element that looks like this in here for it to remove it. That's not what this does. So what I actually want it to do is I want it to be the disjoint of two sets like this. And that's not called disjoint, at least not in this context. Let's go to Clojure set real quick and see if we can find what we're looking for. Difference is what we're looking for here. Okay, so let's use difference. And that means I'll have to bring in a new import real quick. That's okay. Clojure.set as set. Okay. I don't think it'll cause our other calls to set to break or anything like that. So instead of disj here, we're going to want set slash difference between these two. I think that'll do it. Okay. Let's kill that. Come on, baby. Should be faster now. Much faster. ID 741. There's our guy. Wanna bet? Wanna bet? 741. Give it to me. Too high, it says. Okay, well, note that down and keep going. Sad day. Okay. Okay, let's just see what this is giving us, though, in a trivial scenario. Come on. It's not behaving too well right now. Something's causing my machine to lag like crazy. Okay. Something's really causing my machine to lag. Should I reset at some point here? That should be a map. That's a pretty clear intersection. Okay, that's a correct identification. Doesn't matter what the ordering is. It's harder to tell with sets because the ordering is never guaranteed anyway. Take a rect down. Remove the current rectangle from consideration. If there's no items left, those recur. Remainder and collided. That's a little cleaner, I think. Set of collided things. it's not going to show it. Interesting. Okay. Okay, let's try something here. First out of parsed input, disjoint. Let's see, this is a set of a rest of the parsed inputs. If I can type it right anyway. Alright, I left the Latin mode on. Inspect last results. So here's the things it collided with. Seems reasonable. Should be 1,291, I think. There we go. So it is removing the right number. Oh, you know what? We can't remove the other rectangles, of course, because they have to be able to collide with other things. I'm an idiot. I'm just being over-eager in my removal here. Okay, that's my bad. So we don't necessarily need set difference here. Unfortunately, we can only get rid of the current one. Yeah, that's a bummer. Lets me recall, and I've done it again. You've been staring at the website the whole time. I'm really bad at this. Solution B next time is just going to be to have it show whatever's on the screen, so. Ugly as it may be. It's either some or any. I thought that was an any. No, that's for predicates. So, if there is any rectangle that collides, any one, then it'll just return quickly. If it collided, if not collided, then we return the current rectangle. Otherwise, we recur with the remainder. I mean, that's really it. Thankfully, that's actually really smooth at this point. Oh, this is what's been bugging me. We still need a way to say that those rectangles collided with this one. I see now. Okay, now I see why this is getting a little more complicated, and my initial intuition, I think, was correct. Oh, fuck. Okay. Let's nuke these. Alright, so I still need my list of collided things, because now I need to... So, if there were none that collided, then we'll just go ahead and return that rectangle. Otherwise, we'll continue with set. Turn this into a set. Set / difference between remainder and the collided ones. Set / union between that. We don't need union again, we just need into. Into this, we're going to drop our newly tagged ones. Tagged collided. Let's refresh something over here. Okay. So basically we're going to reinsert our tagged items in here. So, if the current rectangle didn't collide with anything else, and it hasn't been collided to by something that came before us, then we're good to go. Okay, this is way more complex than I expected up front. Come on, give me the money. It's going to have to do a lot more comparisons now because I'm not exiting eerily like I was before. It's basically going to have to do around the same number of ones that it did for the very original solution. So, but we do have a solution, 695, less than 741. Come on, 695. Oh, hallelujah, that took way too long. Okay, so we have a solution, and I really fumbled through this one. Okay. And my performance is absolutely in the gutter. Like, terrible, terrible performance. So I'm going to have to figure out how to make that more optimal. But, all I have to say, it's done. Trying to think now if there's any better way to do all this, because that was pretty gross. I think, actually, the original idea where we had an array of vectors, or a vector of pixels, is a good one. And my reasoning is that it's a sort of a cache. We can just write down what the ID was that each square belongs to, and if someone else's ID is there, we mark it with an X, and we go back in and tell all the X's at the end. That way we're not having to do in squared comparison, we just do a linear in comparison by just writing data down right on the spot. I think that's the best bet for this, honestly. So that's going to be my next iteration here, I think. Have I got time? I've got time. I can work this a little more. Let's take some time to do that together here. This is a fun one. I just took forever to do it. And let's see how badly I'm off on the Clojurian's board now. Yeah, someone's really outed me there. Cool. Okay. Yeah. Look at that. Andrew Sinclair, you got this. Okay. Okay, I have an interesting idea here. Instead of doing this using a vector of vectors, because we don't know what the initial space looks like, we could still do this using a nested map of maps. So x coordinate indexes in the first layer, y-coordinate indexes in the second layer, and use update, chain. I think you can use update in for that, and that lets you do nested layers like that. And then we can say, hey, if there's something else there, we'll draw an X. Yeah, let's give this a go. I like this idea. For sanity's and safety's sake, what I'm going to do here is I'm going to copy this file into day 3B, which we will now open. Okay. So instead of overlapping squares, we're just going to say mark squares. So we're going to take a rectangle, mark it squares on a canvas, where a canvas is simply a two-tier map. Let's see, let's actually make a function here. An ID of a rect is simply the ID of a rect. Again, let's work with functions more than keywords where we can, just for simplicity's and readability's sake. Let's see. To mark a single square on a canvas, XY with ID, we're going to say update in the canvas XY how does update in behave in the presence of nil? It's been a while. Update in. If any levels do not exist, types must be created. And I'm assuming that means the initial value will be nil. Great. I'm not sure what like the if there. It usually doesn't like conditionals or macros in your lambdas first thing. No, let's not do that. Okay, hold on. Fn function. Okay, so we'll put a keyword in there, this is collided, if there's another thing that was already sitting there, basically. I think I like that. Not quite. Okay, hold on. Mark squares. Gonna kill this. So we're just gonna say, hey, for every single element in this square, generate an XY pair. Let's actually just give this a name instead. And instead of rect A, here we should be using just rect. So that should give us a list of all the squares in a rectangle. Reduce reduce function of x and y this can be a little bit of ghosting there. Okay, canvas x y coordinates. We'll say so we'll just take all the squares in the rectangle, and one by one we'll mark them all in the canvas and give back the new canvas with all them marked. Sounds good? Sounds good. Okay. And then to overlap them all, that's no longer really needed. So we're going to make sure all the rectangles have each of their individual squares added to the grid now. Okay, now we have a canvas. We want the vowels out of that canvas, aka all the maps at the Y level. That's a collection of maps now. Flat map. What's the... Ah, it's been way too long since I've seen flat map, apparently. Map cat. There we go. I'm going to take each of the values, mapcat vowels. So this will get, okay. This will give us a list of maps from Y to cell value. This will give us a list of lists of cell values, which we want to mapcat into just a list of cell values. So it'll concatenate all these lists together. So we just basically get one long string of all the cells that we've created. And then from there, we want to calculate the ones that have collided in them. I think that works. Oh, no, wait. I need to filter. Hold on. Filter by that. Then I need to count. There we go. That's idiomatic. These aren't run. Let me real quick kill this. No, not that. Hold on. Doesn't like underscore somewhere. There we go. Okay. Oh, and there we go again. Wrong number of args passed to some FN. Not helpful. 39. Okay, doesn't like this, I think. Where did mark squares go? There it went. Okay. Somehow I managed to delete. Oh, I hit evaluate, last, deafen, and replace. Okay. That's why. Let's try this again. Go. Still doesn't like it. Mark squares. It doesn't like it. Oh! I see what's going on here. Okay, hold on a second. This is a function that takes, okay, I see what's going on here. Takes a canvas and a square, an erect rather. Oh wait, no, this is just mark squares. That's actually much nicer to read anyway. Okay. Index out of bounds. It did not like ASOC in. Let's take a closer look at what I wrote up here then. Let me see if I understand updating correctly by trying it out. Update in an empty set, an empty map, the path is going to be 1, 2. If it's nil, curval, then 1 else 0. 0 is 1. So it goes 1, 2, puts in 0 because it's nil. Okay? If I have then 1, 2, 0, I should get 1, 1, 2, 1. Okay, there we go. So it should be working correctly there. So now the next question is why not? All squares for the first of our parsed inputs. Okay, it's a list of tuples. Good. Mark squares on an empty canvas. With the first of our parsed input. And that's where it doesn't like it. This is closing the function, right? Okay. I give it a canvas. Current canvas, the new item is going to be an XY. I ask it to mark the square of that canvas with the XY and the new ID. I am unpacking and repacking a tuple, but I'm not going to worry about that for now. So I know I can mark individual squares. Interesting. Why is it complaining? What's the error again? It's saying it's like turning into a vector or something in here. See, it's saying it's trying to associate in a vector. Do I have the ordering wrong? Let me check update in. Map. Keys. Function. Oh, you know what? I'm not giving it a default. Hold on here a second. Canvas. Aha, I see. It was using the wrong form or something. I was using nil, or I think that's what it was. It was churning by using nil. Now we gave it a base to work off of, and it now can use update in correctly. Okay, let's try that. Much faster. Holy moly, I should have been doing this from the start. Wow, okay. Now, the caveat here is that this technique makes the actual checking for overlap, well, not harder. You have to do some redundant work. You have to like do a simultaneous check whether it overlaps with the old thing as it's updating. Alternatively, you can just run 2 passes and do a check on that area, then a collision check. So let's try this first. We're going to add a new function called sum Oh no, I think I can do this, okay. So if there is a value at any of the squares, then this will turn true. Then we could say first of drop while collides doesn't fit. Canvas, rect. I'm going to use reduced again for like the second time. This is weird. I haven't used reduced as much. Okay, so if I go ahead and say if that doesn't work either. Because I'm doing this thing again where I'm prematurely assuming. But what I can do, hold on, is I can like take the existing map and I can check to see, hey, is there any section or do any of these rectangles just have only IDs of their own and no collisions in their range? That's another way to do this. So, hold on. Given a completed canvas, I want to know if every single one equals let the ID be the ID of the rectangle in this context. if it's just the ID, so if nothing else has been there, if nothing else landed there, then the rectangle's ID should still be in place. And we can quickly vet to see, hey, are all of my IDs intact? If so, I'm good. That's a quick way to vet this after the fact. It's going to take 2 passes, but still 2 linear passes, not 2 in-squared passes. Way faster. So we've done all the work beforehand, and we're just doing a quick tally to account for who it is. So all of my squares are equal to my ID. Then we return true. Okay, let's use a def here. Filled canvas is reduce mark squares blah parse input. That'll be our final map with all the actual squares filled in. And then we can actually just take this and make this into a, oops, it's going too far. Filled. Filled canvas, vowels, etc. If the canvas collides, now instead we're looking for drop while okay, we can make this simpler now. Much simpler. Drop while collides with filled canvas, the given rectangle, out of our parsed input. So for each rectangle, we're just going to go back and check. Grab the first one that we find that isn't colliding. Okay, hold on. Let me kill to the end. Let's comment this out. Rerun the buffer so make sure I have all my definitions in play. And we'll give this a spin. That's not it. That's correct. This is taking me 1 though. So something in this isn't working. Get in canvas x1. Filled canvas %. Okay. 186. Let me check the definition of every. So for all the squares in the rectangle, okay, let's do this more directly. Collides with filled canvas, first in the parsed inputs. False. Oh, I have my predicate flipped. I'm looking for not any. That'll do it. Watch your predicates, kids. No, not any. It collides if there is some. Oh boy, okay. If there is something that does not equal the ID, then it collides. Good grief. Okay, I need to work on my predicates, apparently. I gotta start using spec more. 695. Okay. There we go. And far, far faster than the original solution. So I was headed the right path initially, and I threw myself off the rails, and that took me forever. Now I've got it back on the rails. Okay, this has been a much longer one than the last ones, and I made it harder on myself, so blame me for that trip. But we're done. I'm going to leave it at this. This is a much, much nicer solution. Okay. Let's clean it up a little bit, but I think other than that, we're done. Okay, we can actually do a little bit of work here, actually. Let's just tidy that. Canvas square. And that means that here you can just literally pass in square, square. I think this actually means I can do percent 1, percent 2 here. Alrighty. Okay. Stage. Commit. Add three solutions in Clojure. Fast. Push, and there we go. Okay, so now the solution's up in the repo. We are done for the day. I'll probably try and get this one done in Elixir. Now that I have an optimal solution, ostensibly, I think this is all applicable in Elixir as well. So we'll see if I do that later or not, if I have time or not. Tomorrow's work, I should get to bed. It's late. This is a fun one. I kind of went off the rails with it, but it's always fun to have a problem where you can rethink it, come back with another solution, and see a definitive improvement. This is just me not being smart with my algorithmic complexity. So next time, I'll use an noggin a little more upfront, hopefully. Y'all have a fun advent of code, and keep learning languages. Now, can I turn off the stream? There.